Hi everyone and welcome to this video. So today we're going to be looking at this tool called Beanie, and it is an ODM that helps us to work with MongoDB in the Python programming language. So what is an ODM? An ODM is an object document mapper, and what an ODM helps us to do is to map our database or our NoSQL database into classes that allow us to define how each of the collections can be. Now, if you're wondering what a collection basically is what you can look at as a table in a SQL database or an SQL database. So when working with NoSQL databases, we don't have a defined schema, but then ODMs help us to basically define the structure of the data that we shall be storing in each collection. If you're wondering what a collection is simply a group of documents storing information about a particular entity or a particular topic or a particular subject for this case. Now, a document in the other case is just an entry of data or an instance of the data you're keeping. And this video we're going to look at Beanie and how we can be able to use it to simplify our work while working with MongoDB. I hope you find this video helpful, and without further ado, let us get into the video. Alright, so what shall we need to get started? So what we're going to need is an installation of MongoDB and Python. So I'm currently in my VS Code here. It's what I'm going to use as a text editor, but feel free to use whatever you may want for this video. So I have MongoDB Campus, which is a GUI tool that's going to allow us to see how our MongoDB database is going to be in this video. So let us get started. So I'll head over to the docs right here and shall go to the getting started section. And we are going to follow the instructions for installing Beanie. So I'll do pip install Beanie. But before I do that, I'll have to create a virtual environment and then activate it. So I'll go to my terminal right here. And what I have to do is to first create my virtual environment with Python -m and then call my virtual environment env. Okay, now that our virtual environment has been created, I'll activate it with source env and then scripts and activate. The reason that's why I'm doing this is because I'm on Windows. So this is going to activate my virtual environment. So I'll go ahead and install our Beanie with pip install Beanie. So this will go ahead and install Beanie within our virtual environment. It's actually not Beanie, it's Beanie with I and E. Sorry for this. So after installing it, I'll go ahead and create a requirements.txt file with pip freeze. And then I'll point to requirements.txt. So this will basically go ahead and write our requirements in a requirements.txt file. And when you open this file, we're going to be able to see the various things that it depends on. So out of the box, we can see that it depends on Motor, which is an asynchronous database driver for MongoDB. We can also see that it depends on Pydantic. Now, if you've worked with FastAPI, you will know that Pydantic helps us to create models or schemas that help us to serialize and deserialize our data when working with an ORM and so on. So now, Beanie allows us to be able to create our document classes using Pydantic. These classes can be able to serialize our data. They can also be able to help us to basically store our information, as we're going to see. So after doing this, then the first thing we're going to do is to set up our Beanie. So I'm going to create a file here, which I'm going to call our main.py. And within our main.py, I'm going to begin by setting up our Beanie. Now, Beanie works asynchronously. And this means that we have to define our coroutine. So a coroutine is a function that you write with an async await syntax. So what I'm going to do is to come here and define a function. I'm just going to call this function main. And this function is going to be an asynchronous function or a coroutine. Now, the first thing we're going to do is to create a client using Motor. So since this depends on Motor to help us to connect to our database, we're going to need to create a client and then define how we're going to connect to our database. So I'm going to go ahead right here. And what I have to do is to first import our Motor. So I'll just come and say import Motor .motor async IO. So this basically depends on Motor async IO to help us to connect to our database. So what I'm going to do is to come right here and create a client. So I'll call this client, and this is going to be equal to Motor async IO. So it's actually going to be motor.motor async IO. Then we shall call that async IO Motor client. So it's actually going to be async IO Motor client. Then within here, we can be able to define how we're going to connect to our database. So what I have to do is to come and define the URL to our database or our connection stream. So I'll do this by specifying MongoDB, and then I'll specify our host, which is going to be localhost. I'll also specify the port. So the port is normally 270.17, and then we shall be good to go. So this line is just enough for us to connect to MongoDB. Now, another thing we shall need to do is to basically initialize Beanie to work with our database. But before we do that, let's just first define a document. So a document class is the one that helps our ODM define how we are going to basically create our collection. So let us go ahead and define one. So I'll begin by importing our document class from Beanie. So I'll just come and say from Beanie, we are going to import our document class. And right after importing our document class, what I have to do is to go ahead and define a document. So I'll just come right here. Let's first model out a simple database structure or a simple database collection in this case. So I'm going to create a class, and I'm just simply going to call this task. And once you have this task class, we can have things such as ID, which can be an integer or can be, because MongoDB stores IDs as object IDs. So we may choose to leave this out because it will generate for us automatically. So we can have something like the content of that task, and this can be text. And then we can also have, let's say, an attribute of is complete to show if the task is complete or not. So we can just come and say is complete. And once we have this, then we can also go ahead and specify that it's going to be a Boolean that's going to have a default of false. Now, once we have this, then let us go ahead and define our document. So the way we define our documents with Beanie is similar to how you may write your schema with Pydantic. So I'll begin by creating our class. And our class in this case is going to be task. And this is going to inherit from document. So once we have this, then you can go ahead and use the same syntax of defining our database, actually our schemas with Pydantic. So what I have to do is to define our content. And in this case, our content is going to be equal to, actually it's going to be string. Then we can even go ahead and add some extra validations on here. So we can say this is going to be a field. So I'm going to import Pydantic. We can even see that our requirements here have Pydantic, so we can be able to use Pydantic. So what I have to do is to go ahead and basically define our fields and whatever validations we may need for that field. So what I'm going to do is to import our Pydantic field class. So I'll just come and say from Pydantic, we're going to import our field, which is actually going to be a function. Now, I'll just come right here and say that this is going to be a field. Now, within here, we have all the freedom in the world to basically use whatever validations we may need. For example, we can say that we are going to have a max length. And when you have a max length, we can specify, let's say, want the max length of each of the content for each task we're going to create to be 200. Now, once you have that, then you can also go ahead and specify is complete. And this is going to be a Boolean. So our type for this is going to be a Boolean, And you can also specify that this is going to be a field, and it can have a default. So let's say it's going to have a default of false. So once we have this, then we are good to go. We've been able to define a document that's going to allow us to basically describe how we shall have our task in a collection. All right, so what I'm going to do is to go ahead and use our client to initialize our Beanie so that we can connect to our database. So I'm going to first close this for now, hoping that you guys can see well. Let me enlarge the text a little bit. So when I come right here, I'm going to basically initialize our Beanie. Now the way we initialize our DB is via an await. So we shall have to await Beanie, and then here we have to call dot init. It's actually have to first import Beanie. So I'll just come and say import Beanie, and then I'll have to come and say Beanie dot, in this case we're going to initialize Beanie, and in this case the first thing we shall need is the database. So we are going to first call our database. So I'll just come and say that we're going to use our client, and here we shall use our client to access our DB. So we shall say client.db name, and then it's actually going to be our database. So let me just say database is going to be equal to client.db name, and then we shall also need to basically pass in our database documents. So we're going to say that this is going to be equal to our document model. So a document model is basically a class that we create with our document that inherits from our document class, just like we see here. So this is a list, and it takes in each of the models that you have. So in this case, we only have one model, which is going to be our task model. So once we have this, then we can go ahead and maybe create some data that we can use to populate our database. So right now, when we save, I can go ahead and refer to the documentation right here. So just like we see, for now, we've been able to connect to our database. So we have been able to initialize our DB. So let's go ahead and define some documents. So a document is basically sort of like how you may see a row in our database. Now, if you've worked with an ORM such as SQL Alchemy, you'll notice that each time you're creating a row or an instance, or let's say an entry into your database table, you're going to create an instance of your model class. Now, Beanie works the same way. Like, we need to first create an instance of that document class we've created, and then go ahead and save that in our MongoDB database. So let us create our first task. So to create our first task, I'm going to come right here and say task 1, and this is going to be equal to a task. So once we have our task, then we are going to basically go ahead and provide the content. So I'm just going to come and say that the content is going to be equal to, let's say, learn MongoDB. And once we have this, then we can also go ahead and define our is complete. But since this can be false, so we can actually say it's going to be false. So once we have this, then we can go ahead and basically save this, or let's actually create another one. So I'm going to just simply copy the same line right here. And when I copy this, I'm going to paste it right here. And when I paste it here, I'm going to change this to maybe learn fast API. And let's say I will also have, let me call this task 2. I'm going to also provide task 3. And this is actually going to be task 3. So here we're going to have, so let me say, I'm going to have a task of create a YouTube video. So once I have this, then I can go ahead and insert all these into our database. So the beauty is we don't need to create a database, just like most cases when you're using a relational database. All we need to do is to connect, and MongoDB will help us, actually Beanie will help us to be able to basically create the database and insert all the collections and all the documents that we need for those specific connections. So to be able to insert this data, what I'm going to do is to come right here. So I'm just going to come and say task1 dot, I'll call that insert method, and then I'll also go ahead and do the same thing for task2. So I'm just going to copy this line right here and basically paste it. So this is going to be task2.insert. Now we shall also have task3.insert, and this is going to help us to populate our database. So once we have this, then how are we going to run this coroutine? So we usually use async.io to run our coroutines. So the first thing I'm going to do is import our async.io. So async.io comes already within the Python standard library, so you don't need to install anything. So just come at the top right here and say import async.io. And once you have async.io, I'll just come right down here and say that we're going to say to call the run method on our async.io. So shall just call the run method. And once we have this, then you're going to basically provide the coroutine you want to run. And in this case, we are going to call our main coroutine. So I'm just going to come right here, and all I have to do is to call main. So once I save, it's going to go ahead and basically let me stop the formatter and save. So this is going to save our file, and once we save our file, let us go ahead and run our code. So within my git bash right here, I'm going to come and run our file. So I run python main.py, and this is actually going to run our file. So let us go ahead and look at what to see. So we see a document.insert was never awaited. So what we actually need to do is to await each time we are to insert our documents. So I'll do that real fast. I'll just come and basically Ctrl D to multi to create these cursors, and then I'll say await. So each time for to call these methods, we actually need to await them. And let's go ahead and do that. So once I've done that, so my code formatter is actually telling me to use a formatter. So let me use black. So it's going to go ahead and install black and all that stuff that comes with black. But meanwhile, what I was saying is we need to await each time we are calling these methods on our tasks. And that's why actually it refused to run. But let's await them, hoping that black is installing. And now we see that we've been able to install our black. So once I save, in this case, we are actually not getting any errors. So our code has formatted. So let us go ahead and run our file again. So I'll run python main.py. And now we see that our file has run successfully. So let us go ahead and use our MongoDB campus to see if our database has been created, our collection has been created, and within that collection we also want to see if our documents have been inserted. So I'll head over to my MongoDB campus right here. So when I refresh, I'm actually going to refresh right here. So we basically have 4 collections. I think the collection that you're looking for is the one that has DB name. So I'm simply going to come, and we can see that we have 3 documents right here. So if I open our task database right here, we now see that we're actually having 3 collections. We have the collection that is number 1 that has an object ID this. We also have the second object or the second task and the third task, as we've been able to see. Now the beauty is we can be able to see this in this format. We can also be able to see how it may look like in JSON format. And this is wonderful. Now the next thing we're going to do is to look at how we can be able to query for all our items. Alright, so to list all our documents, what I'm going to do is to first remove these insertion statements. I'm going to just comment them out. Now, the first thing we're going to do is to basically create sort of like a query or a statement that's going to allow us to basically get all our tasks. So then we're going to do that. I'm just going to come and say tasks, and this is going to be equal to. So we're going to call our task class. And here we shall call the method of find. So you can say find, and what we can do here is to basically call that to list method, which is going to convert our object into a list that we can loop through. So I'll just come right here, and what I have to do is to await this, since the to list method only works with it's actually a coroutine, so it should be called with an await syntax. So once we have this, then all we need to do is to go ahead and print our tasks. So I can just come and say print tasks, and when I save, we are going to pull up our terminal right here and then run our file again. And right now we see that this is returning for us each of our documents. We can see that each document has an object ID, a revision ID, which is a UUID, the content, as well as its complete. Now, to make this a little bit more, to make this a little bit good, or to make it a little bit tidy, what I'm going to do is to define a method on our model class or our document class that's going to allow us to return each of the tasks as JSON. So what I'm going to do here is to come right here, and I'll define this as, actually I'll just call this to JSON. Now, since we are within a class, it's going to take in self, and that self will be the current object. Now what I'll do is to just return a dictionary for each of the data that we shall have in a task. So we're going to begin by the object ID. So I'll just come and say here that we're going to have our ID being self dot. In this case, we're going to call it the object ID. Let me actually check. This is going to be the ID, so we can say self.id, and then we can also basically call our revision ID. So I can just say that shall have our revision ID, and this is going to be self.revision ID. Sorry for this. So once we have our revision ID, then we can also provide our content, and this will be self.content, and we shall also call our, so in this case we're going to call our is complete. So I can just come and say is complete, and here we shall have self.is complete. So when I go ahead and save, this case, we're going to loop through each of our tasks. Now, this is actually provided for us. Let me close some of the terminals I have here. So when we run our file, we actually return the list of each of our tasks that we have in our database. However, these are task objects. Now, let us go ahead and look at how we can be able to loop through this and print out JSON formats that are easily readable. So what I'm going to do is to come right here, and all I have to do is to loop through our tasks. Now, I'm going to remove this. And what I can do in this case is to come and say for task in tasks. And in this case, we can just come and print task dot. So we can call our to JSON method and then save. So after saving here, I'll pull up our terminal, clear it with Ctrl and L, and then run our file. And now we can see that we are actually having each of our objects as JSON that can easily be read. Now, to convert this, what we can do is to, actually what I'm trying to do is to convert this from object ID, object, or revision ID, object into strings. What I can do is to just come and specify that instead of having self.id, we shall have the string representation of that self ID. And then instead of having the revision ID as a UUID object, we can come and provide string, and then we shall provide self.revision ID. Now, when I go ahead and save this, we pull up our terminal. When we run this, we are actually going to see that our objects are now being returned as pure JSON, which is going to actually work. Now, this is not the only way we can be able to return all documents or all tasks in our database. So in this case, we can also actually come and call the find all. So instead of saying task.find, what we can do is to come and say task.find all, and this is actually going to work the same way. So if I save, I'm going to run this again, and it shall return the same result. Now you can also be able to return items based on a certain criteria using find still. So what you can do is to basically come right here and say find, and then you provide criteria. So in this case, you can be able to provide maybe a certain criteria. So let's say we are going to search for all tasks that have their is complete equal to false. So let us do that. So what I have to do is to basically specify task, and in this case we can say task.isComplete, and in this case we are going to provide our criteria. So let's say if task.isComplete is equal to false, then we're going to return a list of all the items that have task is complete equal to false. So when I come right here and run this, it's actually going to return all tasks, and all of these are going to have is complete equal to false. Alright, so let us go ahead and create one task that has is complete equal to true. Now I'm going to first comment out all this. So I'll just come right here and comment out all this. Now let's say we're going to basically change task 3 to have is complete equal to true. In this case, when I go ahead and save, I'll also uncomment the command for storing it. So when I come and run our file right now, so simply go ahead and insert this document. So when you go to our MongoDB campus right here and I refresh, we're now going to see that we have our task that has is complete equal to true. I hope you can be able to see this, which is equal to true. Alright, so when you go ahead and basically query for all items with is complete equal to true, our document of our fourth document is not going to be returned. So let us try to actually do that. So I'll comment this and comment this. So when you go ahead and run, we're now going to see that it's going to return for us only 3 objects because the fourth one has is complete equal to true. Now let us change our criteria to is complete equal to true, and this is going to return that one document that basically has is complete equal to true. Another thing that we're going to look at is how we can be able to basically, actually there are a lot of ways in which you can be able to query for specific objects. For example, instead of using these criteria, we can be able to use the PyMongo way of doing things. So I'll create a separate video on PyMongo so that you can be able to also check out that ODM. So I'll just come right here, and all I have to do is to provide a dictionary, and this dictionary will have the following. So let's say it will have the key for which we want to check. So in this case, we may check for, so this may be something like is complete. So it's going to be is complete, and we can specify that we want to check for that those specific items that have is complete to true. So what I can do is to basically run, and now we can see that it actually works the same way. So instead of defining your criteria as task dot something and then you specify is equal to true, you can instead use a dictionary having the key as an attribute you're checking for and the value as that specific attribute you basically want to check. So to update our tasks or our documents in a MongoDB database, all you have to do is to first find out which document you want to update, or to first query for that specific object that you want to update. So the way we do that is by using the same method. So we can use the find method to basically find out what specific document is going to be returned based on a certain criteria. Now in this case, we need only one. Find usually returns a set or a query set or a list of documents. Now for us to be able to query for a specific task, what we shall need to do is to use the find one method. So I'm going to comment this out, and after commenting it out, I'll have to query for a task. So let's say task 3, is going to be equal to, so then I'll have to call our task class and then call our find one method. Now this is going to be awaited, so I'll have to come and say await task1.find1. Actually, it's going to be task.find1, and then in here I can either come and say task. So let us try to find a task by the ID, so I can just come and say task.id, and then I specify the criteria. So in this case we're going to be using object IDs. So lucky for us, Beanie comes with Motor installed, which also comes with a bunch of other things installed, and one of those things is Bison. So Bison is the binary JavaScript object notation, and what this helps us to do is to help us to basically create unique IDs for each of the documents that we have in our MongoDB collection. So just like you see in our MongoDB campus right here, each of the documents has a unique object ID, and for us to be able to search for these IDs or to search for objects or documents based on these IDs, we shall need to use Bison. So I'll just come right here, and all I have to do is to first import our Bison. So I'll come at the top of our code, and then all I have to say is from Bison. So it contains the package called the object ID package that's going to help us to search for our object IDs. I'm going to import the object ID class, and once I import the object ID class, then I'll just come down here, and all I have to do is to search for a task with a certain object ID. So I'm just going to come and say object ID, and here we shall have to pass to basically paste in our object ID. So I'm just going to come right here, and I'll come and copy one of the object IDs we have. So I'm going to copy the one of our task 3, which is this task. So I'm just going to come and copy it and then paste it right in here. So what I have to do is to come and say print our task 3, and when I run this, we're now going to be able to see this specific task with that specific object ID. So I'm just going to pull up my terminal right here, and when I run python main.py, we can see that our document is being returned for us, which is good. So let us go ahead and look at how we can be able to update it. So there are majorly two ways in which you can be able to update a document using Beanie. The first one helps us to set a particular attribute, and the second one helps us to replace the entire document. How are we going to be able to do that? So now that we've been able to basically search for our task with a specific object ID, which we can also do in this way, so let's actually use a simpler format, the PyMongo way. So I can just come right here, and all I have to do is to put in a dictionary, specify the key. So the key is not going to be ID, just like we've called it on our class. It's actually going to be this underscore ID as we see it in our documents. So when I come here, I'm going to just come and say ID, and then I paste in our document ID just like that. So if I run this, it's going to give us the same result. Actually, it's returning none. I wonder why. I think it's because we didn't pass this within our object ID class. So I'm just simply going to create an instance of object ID and then paste in our object ID. So when I save and run our file, it's going to give us the same results. So we are safe. Now let us go ahead and try to basically update this. Now that we've been able to get this, the way we're going to update this in the simplest way is to basically come and say task 3, then we specify the specific attribute we want to update, and in this case let's say the content, and let's say we're going to change this to, so when you see here we had our content as create a YouTube video, but I want to update it to something like, let's say edit the YouTube video. And once I have this, then all I have to do is to call task3.save, and this will go ahead and basically save our task with the updated data. So when I save this, I'm going to go ahead and pull up our terminal, and when I run, we actually see that we never awaited our save, so we have to call await, because this is actually a coroutine, so we have to call await for it to be able to run. So when I save and call our run our file again, we now see that our task has been updated to edit the YouTube video. So this is wonderful, as we can be able to just call these 3 lines and be able to basically update our document or object. Now another way we can be able to do this is by replacing the entire object. Now replacing works in a way that we search if the object exists, and if it exists we can be able to basically replace the entire document. So how are we going to be able to do that? The first thing we have to check for is if the document exists, and if it does not exist, what you shall have to do is to basically go ahead and maybe throw an error to show that that document does not exist. Now that we have a unique object ID that's helping us to query for that specific document, we can be able to search for that specific document. So what I have to do is to go ahead and actually we already searched for that document, we'll be able to get it. So let's say I'm going to add and upload it to our document. So right after providing our new content here, instead of saying save, I'm just going to I'm going to try writing a try except block right here. So we're going to try to replace the entire document. So I'll just come and say await, and in this case we can say task3.replace, and this will go ahead and replace our document. Now I also need to accept, so I'm just going to come and say accept. And what are we actually going to accept? So it's mostly a value error, so we can provide it as a value error. And once we have that as a value error, I want to specify which specific value error we are accepting in this case, or we are returning as an exception. So this is going to be from Beanie. So Beanie always provides for us this, so we shall say Beanie dot, in this case is going to be our exception. So we shall go to the exceptions in Beanie, and then you call the document not found exception. So I'll just come and say document not found, and then we shall simply print document not found. Alright, so once we have this, let us go ahead and try to update our document. So when I pull up our terminal right here and try to run our python main.py, we now see that our document has been updated, and this is wonderful. Now the next thing we're going to look at is how we can be able to delete our documents. Deleting our task is going to be as simple as calling a method on a specific document. So let us try that. So I'm going to close our terminal right here, and all I have to do is to come right here. So let's say we had to find our task with that specific object ID. Now when I come and basically comment this out, I'll just come right here, and all I have to do is to call await, and then here I shall call task3 dot, in this case I'll call a delete method, and once I've called this I'll save. Let us go ahead and try to delete our task. So I'll pull up my terminal right here and run our file. So this is going to run successfully. So when you go back to our Mongo engine right here, or our MongoDB campus, and refresh, we now see that we have 3 documents, yet we had 4, which means that one of them has actually been deleted. In this video, we've been able to look at Beanie, which is an ODM that helps us to work with MongoDB. I hope you've got to appreciate the tool that I've worked on in this video. If you haven't subscribed, please subscribe, leave a like on this video. Thanks for watching guys, and see you in the next video. Bye.